Hey everybody, we're going to start where we left off in review part 1. The next problem on here is number 5, and it says use the rational zeros theorem to find all the real zeros of the polynomial function, and then to use the zeros to factor f over the real numbers. So we're going to find all the zeros or the intercept points of this. So the first thing I want to do is I want to list out all the possible ones. So if we're talking about listing the possible zeros of this function, remember that we have the last number as our whole numbers. The leading coefficient goes on the bottom of a fraction if we make fractions. So our possible options here are all the factors of 8. So I have plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8, and all of those in combination with the 5. So plus and minus 1 over 5, plus and minus 2 over 5, plus and minus 4 over 5, and plus and minus 8 over 5. Now I'm going to go through and do synthetic division to figure out which one of these zeros are true. I think you guys are all in good shape as far as the whole numbers are concerned. So really I'm going to start with the fractions so that we can get some synthetic division with fractions under our belts. So starting with 1/5, I'm going to write my coefficients of my function across the top, so 5, -2, 20, and -8. Process is drop down the 5, multiply across. So 1/5 times 5 gives me 1. Adding that second column, -1. 1/5 times -1 gives me -1/5. If I were to convert 20 into fifths, 20 is 100 fifths. So 100 fifths minus 1/5 gives me 99 fifths. All right, next part. What I'm interested in is 1/5 times 99 over 5 and whether that's equal to 8. So if I multiply those two, it's like multiplying the bottoms, and I get 99 over 25, which is not equal to 8. So I don't have 0 here. Looking at -1/5, 5, -2, 20, and -8. Dropping down the 5, I get -1 this time, so -3, and positive 3 over 5. All right, adding those up again, 20 is 100 fifths, so I have 100 plus 3 gives me 103 over 5. Again, multiplying, I'm looking for it to equal 8, but this one is going to end up being a negative value. So -103 over 25 does not give me 0 here. All right, positive and -1/5 are a no-go. So moving on, let's try 2/5. 2/5, 5, -2, 20, and -8. So dropping down my 5, 2/5 times 5 gives me 2. Adding that up, I get 0, 0 here, and 20. All right, so 2/5 times 20, I can simplify the 5 and the 20 gives me 4, so 4 times 2 gives me 8, and I have 0. Yay! So we already have 1, and that means that my function is so far equal to x minus 2/5, and what I have left is 5x squared plus 20. Looking at this 5x squared plus 20, that's something that is a parabola that opens this way, move 20 units up. So if I'm thinking about it, it opens up, moves 20 units above the axis, so I'm never going to cross the x-axis here. That doesn't have any zeros. Now if I want it in fully factored form, I can factor out the 5. So 5 times x minus 2/5 times x squared plus 4. That turns it into the sum of cubes for the second one, and difference of cubes is factorable, sum of cubes is not. So as far as zeros are concerned, x is equal to 2/5 is my only 0. All right, moving on. Find the domain, asymptotes, x, y intercepts, and graph. So we're going to take a look at this rational function. And remember in class what we did with a rational function first is factor the thing, top and bottom. So top is already factored into x plus 6. Bottom, I can factor out an x, greatest common factor, and x plus 25 is what I'm left with. Remember, if you can cancel something, don't do it until after you find your domain. But the first step we want to do is find the domain. Here I have two values that x cannot be. X cannot be 0 from this piece, or negative 25 from this one. So my domain would be from negative infinity to negative 25. Negative 25 to 0, and 0 to infinity. All right, let's talk about asymptotes. At this point, if I could simplify, I would. I cannot. But when we're talking about vertical asymptotes, we set the bottom of the simplified function equal to 0. So x times x plus 25 is equal to 0 gives me x is equal to 0 and x is equal to negative 25 for my asymptotes. For horizontal asymptotes, then I'm dealing with the degrees of the function. So for our degrees here, the top function is a first degree, bottom function is a second degree, so I have the line y is equal to 0. Alright, I'm going to make a little graph in order to see what we have so far. I think it's pretty cool. Alright, working through this, I've got an asymptote line at negative 25 for x is equal to negative 25, so I need my scale to be pretty big. I'm going to number by 5s this time. Normally we number by 1s, but you should make it fit your data. On the other side too. And here we go. Alright, so asymptote lines at x is equal to 0. So I've got one right here on the axis. One at x is equal to negative 25. And y is equal to 0. So here's what I have so far. Now looking at the next part, I need the x and y intercepts. So x-intercepts. X-intercepts is when y is equal to 0, so 0 is equal to, we can set it just equal to the top of the fraction because the first thing we would do is multiply by the denominator, so we lose that part. So 0 is equal to x plus 6 gives us negative 6 equal to x. So if I were to write that as a point, I have a point at negative 6, 0. And that is right about here. For y-intercepts, I would normally let x equal 0. Now there's a problem with this one in that 0 is not in my domain. So that means that I do not have a y-intercept, which makes sense because the y-intercept is on that vertical asymptote. So you cannot cross or touch a vertical asymptote, which means I don't have a 0 there. Looking at the last part, the sign chart, I put all my vertical asymptotes and all my zeros on this thing. So vertical asymptotes, negative 25. I also put any holes on there, so if I have a hole, that would go on here too. I have a 0 at negative 6, and I have an asymptote at 0. So I have 4 regions that I have to think about. So let's say that we try f of negative 26. Alright, looking at my function itself, what I'm considering is f of x equal to x plus 6 on the top and x times x plus 25 on the bottom. And I'm going to figure out whether each one of those parentheses is positive or negative in each region. So if I were to plug in negative 26 plus 6 is still a negative value, so I have a negative on the top. On the bottom, negative 26 itself is negative, and negative 26 plus 25 is negative. So overall, 3 negatives give me a negative value, and that means that if I'm in the first region, which is to the left of negative 25, the function itself is negative, and it's restricted to this region here. If it were positive, I'd put it on top of the x-axis, but since it's negative, it's down below. Now looking at the next region, I have, let's say, f of negative 10. All right, negative 10 on the top gives me a negative value. I also have a negative in just x, but I've got a positive this time, so here I have plus. Now what that tells me is that for my function, it's going to come in from the top here. It's going to go through, and it's going to touch this 0 here. Now I don't know what it's going to do with that 0. It could either come back up, or it could go through. I have to decide that based on what's between negative 6 and 0. So looking at, let's pick negative 3. If I plug in negative 3 on the top, I've got a positive. Negative 3 itself is negative, and I've got a positive here. So this region is negative. And what that means as far as my graph is concerned is that it comes through and then approaches the asymptote like this. And the last part determines whether it's above or below the axis everywhere else. So f of 1 would give me a positive value on the top, positive, positive on the bottom, or a positive value altogether. And the last part of my function graphically looks like this. My pen went a little crazy there. Here we go. The last part of my function looks like that. All right, this is start to finish a rational function, and you will have a rational function to analyze start to finish on the test. Now moving on to inequalities, these are the things that you have gone through on Wednesday. The first thing we do with an inequality is move everything over to the left-hand side of the equation. So if I were looking at this inequality, and it's a polynomial one, then I have 2x squared plus 5x minus 25 less than 0. And when I'm answering the question less than 0, what I'm actually wondering is when it's below the axis. So the regions of x where this thing is below the axis. This is a square function, so and it opens up. So we're looking for, if it looks something like this, big picture, what my answer to this inequality would be the region of x from here to here. So I'm looking for a region here where it's below the axis. Now I need to find my zeros. In order to do this, I can either find my zeros by factoring, or I can use the quadratic equation. So if I were to try and use the quadratic here, a would equal 2, b would equal 5, c is negative 25. So x is equal to negative b, so negative 5, plus and minus the square root of b squared, so 25, minus 4 times 2 times negative 25, all over 2 times a, so 4. Simplifying inside that square root first, 25 plus gives me 225 inside the square root. That is a perfect square, so 225, the square root is 15. So I have negative 5 plus and minus 15 over 4. Gives me x values. Negative 5 minus 15 gives me negative 20. over 4 or negative 5. And I have x is equal to, if I'm adding 15, I get 10 over 4 or 5/2. So graphically, if you're thinking about this, then you have two different places where this crosses the axis. It crosses the axis at this point, negative 5, 0. And it crosses the axis at this point, 5/2, 0. So the solution set to this particular inequality is the region between those two values of x. So here is the actual answer. It's the region from negative 5 to 5/2. Now those are rounded parentheses because it's strictly less than. If it were less than or equal to, then we would use a square bracket here.